Got a big telecom software testing interview coming up? Yeah, that pressure is real. But don't you worry. Welcome to Enhance Smart Skills. We're all about helping you crack that code. So, over the next few minutes, we're going to get you geared up with the absolute must-knows of the industry. And hey, we're not just going to talk about concepts. We're going to help you show them exactly what you bring to the table so you can walk in there and absolutely ace that interview. You ready? Let's jump in. All right, first things first, the big picture. You know that classic interview question, so tell me what you know about our industry. Yeah, they really want to see if you get the world you're about to step into. So this first section is all about giving you a super clear and confident way to break down the key parts of telecom. Okay, let's make this easy. The best way to think about a telecom network, it's like a giant sprawling highway system. But instead of cars and trucks, these highways are buzzing with data. I mean, everything, from that quick text you just sent to a full-on 4K movie. All of it is just zipping across the globe on these data highways. So if the networks are the highways, you're probably wondering, what's actually on these highways? Well, that's where services come in. These are the cars, the trucks, the motorcycles. They're the products you and I use every single day. Think about it. Making a phone call, sending a picture, streaming your favorite show. Each one is just a different kind of vehicle using that same massive road system. Okay, so what's making all these vehicles go? What's the engine? Well, that's the technology. This is the real magic happening behind the scenes. A perfect example is VoIP, voice over IP. That's the tech that lets you make a phone call over the internet. It totally changed the game, bypassing all those old school telephone lines. It's that kind of stuff, that innovation, that really powers this whole industry. And just like our real-world highways, these data networks have gotten some serious upgrades over the years. We started way back with 2G, which is kind of like a simple little two-lane country road, just for calls and texts. Then 3G came along and gave us our first real taste of mobile internet. 4G, that was the game changer, our first proper superhighway that made streaming video a reality. And now we have 5G. Think of it like a futuristic bullet train, insanely fast, practically zero delay. It's what's going to make things like VR and truly smart cities possible. All right, so you've got the what of telecom down cold, but now we need to talk about the who, because knowing who the major players are, that shows the interviewer that you see more than just lines of code. It shows them you understand the entire business. And honestly, the whole industry really just comes down to four key groups. You've got the service providers, the ones running the show. Then you have the equipment manufacturers, the folks who build all this stuff. You've got the regulatory authorities, who are like the referees. And of course, you've got us, the customers. So let's start with the big ones, the telecom service providers, or TSPs. These are the household names, the giants of the industry. They're the ones out there building and taking care of those data highways we were just talking about. And they're the ones who sell you the pass to get on them. Okay, pro tip for your interview right here. Don't just spit out a dry definition. Give them a real example. You could say something like, well, you've got companies like Verizon or AT&T. They're the ones building out those data superhighways and then offering this whole buffet of services on top of it. See? Using a name they know and tying it back to that highway analogy, that makes your answer stick. Next up, we've got the equipment manufacturers. So if the TSPs are building the highway, these are the folks who actually make the asphalt, the signs, and the guardrails. They're the ones designing and building all the critical hardware, the routers, the switches, the cell towers, and all the software that makes that gear actually do its job. And hey, just like before, dropping a few names here really shows you've done your homework. You can explain it like, yeah, companies like Cisco and Nokia, they're the ones crafting the actual building blocks of the network, from the physical hardware to the complex software that brings it all to life. It just shows you get the bigger picture, the whole supply chain. Now, think about it. You can't have a huge highway system with no speed limits or rules of the road, right? It would be chaos. In the world of telecom, that's where the regulatory authorities come in. They are basically the traffic cops and the lawmakers of the industry, making sure everyone plays fair and that we, the consumers, are protected. And here's another pro move for that interview. Being able to name a specific one is a huge plus. You could say something like, like the FCC over in the US or Ofcom in the UK. They're the ones setting the rules, managing things like radio spectrum, and really just looking out for the consumer. It shows you're not just talking theory, you know how this stuff works in the real world. All right, listen up, because this next part is maybe the most important bit of all. We've talked about the industry, the players, the tech, but now we need to connect it all back to you. Why is your role as a software tester so unbelievably crucial in this whole thing? Let's get into it. This is the message you need to land. As a software tester in telecom, you're not just squashing bugs. You're basically a guardian of our connected world. A single, tiny glitch isn't just a, oops, no way. It can take down businesses, disrupt emergency services. It can impact millions of people. The stakes are just incredibly high. And this is where you can really spell out your value. You can explain how poor testing isn't just one problem. It's a domino effect. First, you get service disruptions. That can open up security holes. Then customers get angry, and before you know it, the company's reputation is in the gutter. Your job as a tester is to be the firewall that stops that first domino from ever falling. Okay, last section. Let's wrap all this knowledge up into a powerful pitch for yourself. How do you clearly and confidently explain why your specific knowledge of this industry makes you the person they need to hire? So here's what you can say. This is your strategic advantage. You tell them, look, my domain knowledge means I have a much shorter learning curve. I can get started and contribute from day one. You can say it means I'll have better test coverage because I already know where the tricky telecom-specific problems like to hide. Then you add, it also means I can collaborate way more effectively because I speak the same language as your engineers. And the big finish, and most importantly, it means I know how to think strategically about testing to focus on the things that matter most. Now that is how you sell yourself. So I'll leave you with this question to think about. When you walk into that room and they hit you with that question, so what do you know about telecom? What's your opening move? What's the first thing you're going to say? Are you going to lead with that highway analogy? Are you going to talk about being a guardian of connectivity? Because how you start that answer, it sets the tone for the whole interview. Think about it. You've got this. Good luck. Welcome to Enhance Smart Skills. So you've got a big telecom testing interview on the horizon? Well, you've come to the right place. In this explainer, we're going to break down all the key concepts you absolutely need to know and, more importantly, transform them into the kind of clear, confident answers that are going to really wow any hiring manager. Okay, let's dive right in and get you prepped. We're going to walk through the big questions that always, and I mean always, come up. We'll start with the fundamentals of architecture and work our way all the way to proving a network can actually survive a major failure. If you stick with me, you'll walk out of here with a rock-solid game plan for any question they can possibly throw at you. First things first, network architecture. You can pretty much bet this is where the interview will start. Why? Because they need to know if you get the big picture, the fundamental blueprint of how all these complicated pieces connect and talk to each other. So, how do you absolutely nail this question? Look, don't just start listing off a bunch of technical components. The best way to answer this is with an analogy. And my favorite, the one that always works, is the data highway. It's simple, it's memorable, and it shows you can explain really complex ideas in a way anyone can understand. So let's break down the three main parts of this system. First up, you've got the access network. Just think of this as all the local streets and on-ramps that connect you and me to the main highway. In the real world, this is your Wi-Fi at home, your DSL connection, or that 5G signal your phone is grabbing from the nearest cell tower. It's that last mile connection. Next, we have the core network. This is the backbone. If the access network is the local roads, the core is the massive 8-lane superhighway. It's built with these incredibly powerful high-speed routers and switches that are just designed to handle insane amounts of traffic and get it where it needs to go, fast. And finally, the backhaul network. This is that critical piece in the middle. It's what connects all those local on-ramps to the giant superhighway. Think of it as the network of roads that gets all the traffic from your local cell tower and onto that huge fiber optic backbone. You see, without the backhaul, all those on-ramps would just lead to a dead end. So here it is. This is the key takeaway, the phrase you want to leave the interviewer with. You tell them, testing these parts one by one doesn't tell you much. The real job is testing how they all work together, end to end, to deliver seamless connectivity. That phrase right there, that shows you get the real job. Okay, so you've just knocked the architecture question out of the park. The very next thing they're going to say is, all right, so how would you test it? This is where they want to see if you can think strategically. So let's get into the key approaches. The best way to answer this is to break your whole strategy down into 3 super logical steps. It's a really simple way to frame your answer. First, does the thing even work? That's your functional testing. Second, does it work under pressure? When everyone is trying to use it at once? That's load testing. And third, what happens when something inevitably breaks? That's your fault tolerance testing. Let's make this real with some examples. For functional testing, we're talking about the basics, right? Can a user actually make a phone call? Does the internet even connect? For load testing, you're trying to recreate a massive event, like a huge concert or a major sporting event, to see if the network buckles under that sudden surge. And for fault tolerance, well, that's the fun part. You're intentionally breaking things to see if the network has what it takes to survive. Great. So you've laid out your strategies. Now, a good interviewer is going to probe a little deeper. They'll start asking about the specific challenges of performance testing, because they want to see if you really understand the tricky parts. A classic question you're probably going to get is about the difference between testing a wired network versus a wireless one. For a wired connection, say fiber optic cable, you're in a controlled environment. You're mostly focused on stable speed and pure bandwidth. But with wireless, oh man, the game completely changes. Now you're battling this chaotic world of radio interference, walls blocking signals, and people who are constantly moving around. It's a whole different beast. And it's not just about wired versus wireless. You've got to be ready to talk about these other major performance hurdles, like seamless roaming. Can you drive down the highway on a call without it dropping as you bounce from one cell tower to the next? Or network handovers, that split-second, totally invisible switch your phone makes when it goes from a 4G to a 5G network. And the really big one these days, scalability. What happens when a million new smart devices suddenly connect to the network all at once? Does it collapse? Okay, we're on to the final area they're going to grill you on. This is all about making sure the network doesn't just work well, but that it's also resilient. This is about building a network that can, take a punch and keep on going. First, you have got to lock this definition down, because the crisp, clear answer just screams confidence. Resiliency isn't about preventing every single failure, because let's be real, that's impossible. It's about building a system that can recover so quickly, so effectively, that the person using it never even has a clue that something went wrong. An interviewer might just ask you this point blank. It's a scenario-based question to see if you can actually apply what you know. They're trying to figure out if you really understand how to test for failure. And here is your perfect answer. You just walk them through the redundancy test. Step 1, in a controlled lab, you simulate a failure. You literally go and unplug a key piece of equipment. Step 2, you verify that the network's built-in intelligence automatically reroutes all the traffic onto a backup path. And then, the most important step of all, step 3. You confirm that from the user's point of view, absolutely nothing happened. The video call didn't drop, the download didn't stop, the service was never, ever disrupted. And if you want to leave them with one final, powerful line that they'll remember, it's this. A resilient network isn't one that never fails, but one that fails gracefully. That's it. Your job as a tester is to make failure completely invisible to the customer. That is the ultimate goal. So there you have it, a complete framework to confidently tackle the toughest questions in a telecom testing interview. But here's one final tip to really leave a lasting impression. At the end, when they ask if you have any questions for them, flip it around and ask them this. It shows you're not just thinking about today, you're a forward thinker, already wrestling with the challenges of 5G, the Internet of Things, and whatever comes next. Thanks for watching Enhanced Smart Skills. Now go ace that interview. Good luck. Welcome to Enhanced Smart Skills. All right, let's talk about something that's absolutely critical if you're a software tester in the telecom world. Protocols. In telecom, it's all about communication, right? But what happens when the devices can't even talk to each other? Well, that's where you come in. Today, we're going to crack the code on these protocols. Basically, the secret language of the network. If you can master this, trust me, you become absolutely indispensable. So let's jump right in. Okay, so let's dive into the big question. What exactly are telecom protocols? Honestly, the best way to think about them is as the official language of the network. You know how we have rules for grammar and syntax to make sure we understand each other? Well, it's the same thing for devices. Protocols are those super strict, non-negotiable rules that every device has to follow. It's how we make sure every single piece of data, every text, every call, gets to where it's supposed to go. Perfectly understood. To put it another way, imagine trying to drive in a city with absolutely no traffic laws. No stop signs, no traffic lights, nothing. It would be total chaos, right? That's exactly what a network without protocols would be. Just a massive digital traffic jam. These rules are the traffic signals of the internet, making sure every message, every call, and every video you stream flows smoothly and doesn't crash into anything else. All right, let's get into some of the big players. First up, SIP, or Session Initiation Protocol. Anytime you make a call on an app like Skype or Zoom, SIP is the one working behind the scenes. It's like the host of a party. It sends out the invitation to start the call, it makes sure the conversation keeps going, and when you're done, it's the one that says, "All right, party's over," and hangs up the call. It's the master of ceremonies for all your real-time chats. Next, we've got VoIP, Voice over Internet Protocol. Now, you've for sure heard this term, but here's a key thing to remember. VoIP isn't really a protocol itself. It's the technology that makes internet calls happen. So when you're calling someone on WhatsApp, VoIP is the magic that takes your voice, chops it up into these little digital packets, sends them flying across the internet, and then boom, reassembles them perfectly on the other side. It's literally what turns the internet into a giant phone line. And of course, we can't forget the old school workhorse of the phone network, SS7. Ever sent a text message to a friend who's on a totally different carrier, maybe even in another country, and wondered, how does it know where to go? Well, you can thank SS7 for that. It's the hidden signaling system that handles all the heavy lifting, like setting up traditional phone calls and making sure your texts get delivered to the right number no matter where it is. It's the backbone of it all. Okay, so understanding the language is one thing, but for you as a tester, your job is way bigger. You're not just a translator, you're more like the editor-in-chief, making sure every single one of these digital conversations is absolutely flawless. So how do you actually do that? Let's get into the nitty-gritty of testing. You're really going to focus on 3 critical areas. First is message sequence testing. You've got to make sure the conversation follows the rules, that the back and forth happens in the right order. Second, load testing. This is where you see if the system can handle a huge, massive flood of traffic without just falling over. And third, of course, is security testing. You have to make sure these conversations are private and protected from any bad actors. Let's double down on load testing for a second, because this is huge. This is where testers really earn their stripes. Think about it. It's the Super Bowl, the last 2 minutes. The whole country is streaming the final play. Your job as a tester is to make sure the entire system doesn't just crash and burn right at that moment. It's about simulating that insane peak demand to find the system's breaking point before your customers do. Okay, but let's be real. In the real world, testing protocols isn't always a walk in the park. It's not always clean and simple. You're going to run into some pretty common, but really critical challenges. And being prepared to solve them, that's what separates the pros from the amateurs. And this, right here, is what it's all about. This slide shows how your role goes way beyond just testing. You're not just a bug hunter. You are a problem solver for some of the network's biggest headaches. When different systems refuse to play nice together, that's an interoperability issue, and you fix it. When calls have that awful lag, you're the one who nails down the performance issues. And with security threats changing every day, you're the one keeping things locked down. This is your value, right here. So why does all this matter for your career? Why go this deep? Because honestly, mastering this language gives you a massive advantage out there. This is the stuff that takes you from being just another software tester to being a go-to telecom expert that every team wants. So let's wrap this up with the key takeaways. The big thing to remember is that protocols are the absolute foundation, the language of telecom. Your job is to test that language for 3 things: its sequence, its ability to handle a load, and its security. And when you do that, you become the solution to those huge challenges like interoperability and latency. The bottom line? This knowledge makes you a seriously invaluable asset to any team. This really brings us to the final thought. Now that you know the language of the network, what kinds of conversations are you going to test next? It really shows the power you have as a tester. You're not just clicking buttons. You are safeguarding the very systems that connect our entire world. So keep enhancing those skills, keep asking the tough questions, and we'll see you right back here for the next explainer.